somebody's just asked me, is this a dot here? It is a dot. Okay, and I put that there to show that that is multiplying that, but normally we don't bother when we've got this kind of layout. So that is actually, in Britain, we tend to use a cross, don't we? Like that for a multiplier. Actually, that is the official symbol of dots. That's like the SI unit for this. The other thing is, we actually also use, let's say, 1.2. We use a dot for decimal place and it should be on the line. But if you go to Europe, if you've been to Europe, you've been to France and see price of things, 1 euro for example, that would be 1,2. That's what they use, the decimal point. Just for your information. Right, so I'll put that dot in there and then afterwards I won't bother. If you see two things together, pushed up against one another, then that means that it's a multiplier. Okay, standard procedure that we have. Okay, Ishi, are you with me? Right, so let's get going because we didn't make much progress last time, so let's get things moving a bit.
We did a lot of progress.
Yeah, wrong kind of progress, I think. So what do? We decide, I know we started this last time, but we do need to recap it. Yeah, we decide what is a U, what is a V. You can label it if you wish, you don't have to do, that's my V by the way, not an R. Okay, just to clarify that. Okay. And you can do them the other way around, it doesn't matter on this part. It'll matter when we do the quotient rule in a bit. Okay, so, listening? So U, this says that we just use it as it comes. This says we just use it as it comes. A U. Grab a seat quickly. So we just use U as it comes. Nothing done to it. Not differentiated. Nothing added to it. Taken away. No sauce on it or anything. Just as it comes. So it's 2e, 2x. And then it's times, it multiplies the derivative of the other term.
That's cos.
Which is cos, yeah. Don't forget the 2 though. So 2 comes out to the front. So this should be dy dx equals, because we're finding a derivative, we're finding the gradients. The stuff in the bracket stays the same. Right, now we do the opposite, and we add it to it, the opposites. So we do a derivative of this, a non-derivative of this, sorry. Take this as it comes. This is sine 2x times the derivative of this. So that's going to be 4e 2x. The stuff at the top that would be in a bracket in a lot of calculators stays the same.
So why is it 2 cos?
The 2 here, this value that's inside the brackets comes out, is copied out to the front, multiplies anything that's there, which there's something there, it's a 1, but we don't write it. And then we can tidy it all up, tidy it up. You can sometimes rearrange things, but in this case there's no rearranging, just tidying up. So this 2, for example, bring this to the front and multiply it into that. So we would get 4e 2x.
Why is it 2x?
Because that's what it started as.
Shouldn't it be just x equals
No, because you don't take anything away when it's in this exponential function. Okay, it's the same way you don't take anything away from this. It stays in there, it stays the same. Think of it, it's actually supposed to be in brackets because it's a function, and anything in the bracket stays the same. There's a way to remember. Cosine 2x plus, and again, I'll bring this to the front because that's it's not important, but it's a standard way of writing it, that we tend to put the trig functions at the end. So that's complete now. That will give us the gradient at any value on this waveform that we have. Okay? Right. Got that down? So if we look at another one. Go on. Spare pen. So millions of people see this online, me giving you a pen. didn't say your name, you'll notice.
So only 18 people
So
watch
you-
it here.
New method of humiliating students. Because of course millions of people will be watching this video. Right. Okay. Let's have a look at another one.
Wait, 1 second, 1 second.
I'm going to leave that one on. You can copy that down. Okay. So another one. Let's say. Let's go with that. And so this is a natural log. Remember, natural log. Remember, natural log is the same as log to base e. Should be an x there. Okay, that's what it means.
42x cos is a bracket.
The 2x's.
After cos is a bracket.
Yes, I've missed it out.
And that's missing out.
Just testing you. Yeah. Okay. Right. So same again. We'll say the first term is u, the second term is v. Apply the same principle. It starts to get easy after this. I'll probably only do one more example. When we do the quotient rule that we're going to do next, you're doing the same process.
Yeah.
So if you can do one, you can do the other.
And what does it say up?
It's log x, natural log, log x. I haven't found a way of writing natural logs neatly where it's obvious what it is, to be honest. Okay, so same again, this as it comes, that should be y equals dy dx equals 3x minus 3 times the derivative of v. So yes, 1 over x, well done, yeah. So I can write it there, or I can write it underneath like that, it's the same difference, times 1x. I'm going to do it like that because it's neater. Plus, so v as it comes, log of x, times the derivative of this. So 3 times doing a derivative. I trust you've all got these nailed down now. Times by the power, so it'll be minus 9.
9 minus 2. Right,
Yeah. What, sorry?
oh, minus 4.
Minus 4.
Yeah.
Okay, minus 4. Because you're taking 1 away from minus 3. Okay? A bit of tidying up there. We'd take this minus sign to the front, and then that would make that plus a minus. And so we'd leave it
Karen, how did you get 4?
here,
Yeah,
because you've got minus 3.
yeah.
So on your number line, you're at the minus 3 position, you move to the left.
Oh, you know what the minus is back, but nothing there.
So you always take 1 away,
Why?
because that's the shortcut.
So why did you minus 9 from then? You said minus 9?
Minus 3 times.
Right.
3 times
Remember the steps, you take the power down and multiply it into what's in front.
Yeah.
Oh, so that's a separate number then?
But that's a minus, so that'll make it minus 9. 3 times 3 is 9, minus 9. Then take 1 from the power.
Why did you take 1 from the power?
Right.
Yeah, you said you were going to tell us today.
No, I didn't say I was going to tell you.
Yeah.
You don't want me to go through that. If you do want me to go through that,
No,
I
we
will
don't.
show you.
That's alright.
There's plenty of YouTube videos will show you where it comes from in first principles. It's not actually, there's not a reason, it just turns out to be a nice convenient shortcut. If you do it from first principles, in every situation it ends up being that if you multiply by the power into the number in front, the coefficient, then take 1 from it, you get the right answer. It gives you the same answer as doing it the long way. Okay, I did mention this when we did the first video, when I showed you the gradient, and it's making that distance smaller and smaller. I can show you the maths if you really want, that the Newton-Leibniz did. Okay?
How did it 2 cells?
Don't know, no idea. So 3x minus 3 over x. We can't cancel anything.
No, we can't.
We could actually bring that down to the bottom and then bring them together actually, but let's not.
And then let's
Minus 9x minus 4 times log x. Okay? A bit of tidying. We could do some more tidying in this actually. That means that would come down to the bottom and we can actually add them together and then x to the 4. Actually. Okay? Could do that. Because that's a -1 as well. If I bring it to the top.
Is that minus
And then you add them, don't you? If you multiply, you add them.
How do you know it's -1?
Won't that be minus 3x?
Because it's below the line, it's a divider. I can bring that down or take that up, either way it ends up being the same.
Will it be -4 or minus 3x?
That's it.
Because x is the same as a normal number, x is a normal number.
Yeah, correct, but we know it's to a power of, this is a power of 3, this is a power of 1.
Yeah.
If I take that to the top, it'd be -1, so I'd have -3 times minus, x to -1. So you just add them together, don't you, and you add in a negative, so you get that. Okay? Okay? Obviously, nothing wrong with that as an answer, that is the correct answer, and that will give you the gradient of any value of x. But that's just a bit neat, and that's even neater still. I mean, if you think about it, if you put it in your calculator to get an answer,
Yeah.
you're going to want to put that in, aren't you? You're not, because that's easier. Okay, let's just do one more, and then we'll do the quotient rule. Right, back in black. So let's, there's not much, I can't really think of any more to do really. 4x
Just make your own answer.
to the 2 times, what have I not done? I think I've just done just about everything. Cos 2x. Okay, same thing again, same process. I'll go through it quickly. That's y equals dy dx equals, so 4x squared. So a couple of you are asking about this process, aren't it? You're asking. The power goes down to the front, does it not? Yeah. So it's going to be 8. Is it going to be? Pardon?
Times 2 by 4.
It's going to give me what? What's it going to give me? 2 times 4? I did say it was easy, this. 8. So what happens to the 2?
What did you say?
What happens to the 2?
Take away 1.
Take away 1, 2 minus 1 is 1.
Yeah.
I can put a 1 if I wish, but we don't need to.
Yeah.
I've actually done that the wrong way around. It doesn't actually matter as long as you do the opposite with the other one, but it's not following my rule. So if you don't mind, we'll come back to that. It's 4x squared times the derivative of cosine 2x, which is
-2.
So how did you get that?
look square.
No, the million of people are gonna watch this. Yeah.
Okay, back to first. It shows you should listen on all the other classes I teach. The cosine becomes sine, but it gains a negative sign as well. The stuff inside the bracket goes to the front, so the 2 comes out and copies to the front. The stuff in the bracket stays the same. Have you got that issue?
Yeah.
Okay? And then it's a plus. Right, other thing I need to do, what do I recommend when you get a minus sign, when you're doing multiplications? For clarity, so there's no confusion. If that there is multiplying that, if I turn away and look back at it, I'll see it as a subtract, and it's not a subtract, is it? It's a multiply. So put it into brackets. We'll tidy that up in a minute. Right, on the other side, this as it comes, nothing done to it, nice and easy. Funny bracket is that. Okay. Times the derivative.
So half an hour gone.
Start at half 8.
Oh.
So you were telling us about the rules and that.
How come there's no 8x in that?
This is a bit I'll have to edit out of the video. We've got a departmental rule. If if you're half an hour late, you're not allowed in. But because you didn't know, I'm going to let it. Well, you're just in time actually. For pedantic.
Just in time for that.
Anyway, sit down, let's get going. You bring me calculator?
No, that's not going to do it, sir. That's not going to do it.
I say I'm going to let it go today, but in future it won't be allowed in.
So it's 8x.
You just don't bother turning up.
8x.
And this will definitely have to be edited.
So it's half 8.
Yes, 8x.
Thursday.
Have a seat, glasses. 8x to the 1. And then we'll tidy it up. We're going to end up with a minus sign out front here. And we don't like that.
Is it,
No, that's there. This is just it as it comes, nothing done to it. And then it's here, there's your 8x to the 1.
is that adding or
Have a seat.
So next week I'll come in at half 9.
Let's finish this. Let's finish
I'll
this.
go 5.
Okay, then I can tidy this up. So this minus sign here, I can bring to the front. But we don't, if we can avoid it, we don't like to have a minus sign at the front of an equation or expression. So what we'll do is we'll bring this to the front to make it nice, shall we say. Plus 2x with the 8x at the front of there. We like to have the trig functions at the tail end, so bring the 8x to the front. Minus, bring this 2 together with this 4. 2 times 4 is 8. X squared sine 2x. Okay? Have we got everything there? I think
So where's the minus 2 sign gone?
I've multiplied it into this 4 here, which gives me 8.
Using this as a